And for the fourth part of computational thinking, we're going to talk about algorithms. So algorithms, they're step-by-step instructions that are used to solve a problem. Now, when we solve a problem, it's important to create a plan for our solution. And algorithms, or creating them, is a strategy that we can use to determine the step-by-step instructions that we're going to use to solve a problem. When we actually write algorithms in this course, we're going to write them in a language called pseudocode. Now, pseudocode is kind of a quasi-English, quasi-programming language. There are no real set rules. We do have some QCAA approved guidelines that we will get into when we get to it. But algorithms written in pseudocode are about getting the idea across of what steps need to be taken. We just want to list the way things would be done. Now, we use algorithms all the time, okay? The common example is recipes. So when you cook a recipe or follow a recipe, you follow a series of steps. You get a certain number of items out of the cupboard, you have the right ingredients, you have the right quantities, and if you follow the steps in the right order, then you'll get the result. That's one example of an algorithm. But there's heaps of other algorithms. You see them when people play sports or when they follow directions on their map or they make something out of Lego. They're always following an algorithm. So when you're creating an algorithm, what you're really interested in is you're saying, what's the first step that you could take when you solve the problem? Okay. And you ask you what other steps are needed when you solve this problem, and in what order should those steps be completed. So you're basically creating a set of instructions.